Hello and welcome to this lesson about adding and subtracting fractions. The learning target of this video is to add and subtract fractions and mixed numbers. So let's talk about the process that we're going to need for adding and subtracting fractions. The first part is by far the most important, and that is that you have to have a common denominator. Once you have a common denominator, you can then combine your numerators. And so that leads to sort of the second point I want to get across, which is that only the numerators change. To be more precise, only the numerators get added or subtracted. One thing that drives math teachers absolutely crazy is when we have a problem like this and people say it is equal to 3/5 because they added the 1 to the 2 and the 2 to the 3. That is not how that works. So please do not do that. And then there's one final thing that we have to keep in mind when it comes to adding and subtracting fractions. That is, simplify at the end. At the end. If you can reduce your fractions, you should reduce them. Now, let's talk about what we do with mixed numbers. So mixed numbers are where we have something like 3 and a half. Now, we have two options for what we can do. First option is what I'm going to call the fail-safe option. You will never go wrong if you use this method, and that is to make it an improper fraction. And so by that, I mean you kind of do a C technique, as I like to kind of describe it, where we'll go 3 times 2 plus 1. So 3 times 2 is 6, plus 1 is 7. And so we treat this as 7 over 2. Now, if you want to, you can deal with the numbers and fractions separately. So deal with, and what I mean is you can focus on just the 3 and the 1/2. Because sometimes, depending on what that whole number is, or depending on what that denominator, or the denominator, you could end up working with really big numbers. And it might not be that complicated just to deal with the numbers and the fractions individually. So we'll now take a look at several examples and see how we can put this into practice. Let's say we have the fraction 1/2 plus 2/5. Well, first we have to get a common denominator. And so what I like to do is identify what that common denominator is going to be. And so I'm abbreviating that as CD. And I have to look at these denominators and find a common multiple. So way back in the day, you probably did a little bit of work on finding least common multiples, and that's why. So that way you can use it in fractions. And so the common multiple of 2 and 5 is 10. And so what I need to do is rewrite these in terms of tens. Now to do that, I need to ask myself, what am I going to multiply 2 by to get 10? And that's going to be 5. And then when you're dealing with fractions, you have to multiply by a quote-unquote 1, which is what 5 over 5 is. And then we do the same thing with the 2/5. We need to multiply the 5 by 2, and then so we'll do it in the numerator and denominator. You could easily reduce that to be a 1. What we're doing is it's a dressing up thing. We're putting on a costume for our fraction. And so 5 over 5 times 1/2 is going to be 5/10, and then 2/5 times 2 over 2 will be 4/10. Now we have a common denominator, so we only add the numerator. So we only deal with these numbers right here, and so we'll get 9 over 10. Now, let's do another example, but this time with subtraction. So here, again, we want to try to find our common denominator. And the reason why I want to use this example is to show you that you don't always have to change both of them. So our common denominator is just 12. And so when we rewrite it, 7/12 will stay the same, minus, and then we have to ask ourselves, how am I going to get 6 to 12? Times it by 2, and if you do that in the numerator, or the denominator, you have to do the same thing in the numerator. And so now we're looking at 2 over 12. And again, just combine the numerator, so 7 minus 2 is 5 over 12. See if it can be simplified, and it cannot. Okay, so now let's kick it up a notch, and let's talk about mixed numbers. So for this example, let's say we have 6 1/4 plus 2 1/5. Now, we have two options. Option number 1 is to do improper fractions. So that's where we let the numerator be larger than the denominator. So improper fractions. The second option is where we kind of work with it separately. Work with it separately. That's what that word is over there, separately. All right, so let's do both, just to kind of show you how this works. So again, the fail-safe is to go improper fractions. So we'll figure out what this is going to be. Our denominator is going to be 4. 4 times 6 is 24, plus 1 is 25, plus, do the same thing here, 5 times 2 is 10, plus 1, 11. And now, this is very similar to the problems we were just dealing with. It's just that the numbers are going to be much larger. So you're going to have to do a little more scratch work on the side. Try to find a common denominator, and the common denominator here is going to be 20. And so I'd have to multiply by my 4 by 5, so 5 over 5 here. And then the 5 would be multiplied by 4, so 4 over 4. And again, you can see where the numbers are getting large. 5 times 25. If you don't know that off the top of your head, you have to do some scratch work. It could slow you down, but that's 125 over 20, plus 4 times 11, 44 over 20. And again, we got some numbers we got to crunch here. So we have 4 plus 5 for 9, 4 plus 2 for 6, and then a 1. And let's see here. All right, good. Let's see. Yes, all right, very good. Over 20. And then we have to see if we can simplify it. I don't think we can simplify this. This is as far as that's going to go. And if we had to leave our answer as an improper fraction, we're good. But where we get tricky is taking this number and then putting it back as a mixed number. And that could be a lot of work. And now you have to do, some long division. So, depending on what the answer is or what the answer you asked for, that's why it might be helpful to work with them separately. So let me rewrite my problem. 6 1/4 plus 2 1/5. So we're going to do the same problem, but now we're going to do it where we work with it separately. So we're going to take our two numbers, go 6 plus 2, and then we'll take our two fractions, 1/4 plus 1/5, and we know that we're going to marry them back together when we're done. And so here we'll get 8, and then we'll do the 1/4 plus 1/5, so 1/4 plus 1/5. Common denominator is still 20, still times it by 5 over 5 and 4 over 4, and so you'll get 5 over 20 plus 4 over 20, and then that means that this is 9 over 20. So 9/20. And now we have a good mixed number. So these are the same thing. It's just that this will always work. And then when I do a subtraction example, you'll see why this might fall short for us, because it can be tricky. But this gives us a nice mixed answer. So let's do one final example. Okay, in this one we're going to do 5 2/3 minus 1 4/5. So again, we have the two strategies. You could do improper fractions, or you can work with them separately. This time, let's work with them separately just to kind of show you why this method doesn't always work out well. I mean, there's a workaround, but you have to be paying attention. So, take our numbers, 5 minus 1, that's going to be 4, piece of cake, right? Then we'll take our fractions and do them separately, 2/3 minus 4/5. Uh-oh. Here's the problem we have. 2/3 is smaller than 4/5. So, well, first, maybe let's get a common denominator and do all that other stuff. So let's do that up here. 2/3 minus 4/5. Our common denominator is going to be 15. So times that by 5 over 5 and 3 over 3. And so we'll have 10 over 15 minus 12 over 15. Okay, so what we need to do is go to this 5 and borrow it. We're going to borrow one of those numbers. And so instead of it being 5 minus 1, it's now going to be 4 minus 1. So that 4 as our answer is no longer valid. And what we're going to do is we're going to add an additional 15 over 15. So when I borrowed the 1, that's what we have right here. This is the borrowed 1. Borrowed 1. So now my arithmetic problem is becoming 25 over 15 minus 12 over 15, which is 13 over 15. And so now I'm going to do the 4 minus 1, not 5 minus 1, to get 3, and then bring this over here for 3 and 13 over 15. So that's where this whole doing or kind of breaking the two pieces might not work, or it could be tricky. You just have to catch that. You got to make sure that you borrow a 1, but you add it as a common denominator and whatnot. So sometimes it might just be easier to do the other method where we make it improper fractions. So do our little C thing. 3 times 5 is 15 plus 2 is 17 over 3 minus, and then this is 9 over 5. We know the common denominator is going to be 15, and so times u by 5 over 5 times u by 3 over 3. Might have to do a little bit of scratch work, but 5 times 17 is 85 over 3 minus, and then that's 27 over 15. This is not over 3, it's over 15. Very good. And now we have to do our subtraction. So 85 minus 27, that's going to get us, so let's see here, 85 minus 27, that gets us, so 15 minus 7 is 8, because we had to borrow to make that a 15. 7 minus 2 is 5, 58, and so we'll get 58 over 15. And then, we can kind of cheat here and realize, all right, so I need 3 and 13 fifteenths. So let's see, how many times does 3, or what is 3 times 15? That would be 45. And so, let's see here, so 3, and then 58 minus 45 is going to give me that 13 fifteenths that I need. And so it's the same thing. So again, the fail-safe is to use improper fractions. But again, we're dealing with larger numbers, can be tricky, and here we're dealing with smaller numbers, but we just have to watch out for that borrowed 1. But this just goes to show that, there's always, multiple ways you can get to the right answer. But just all about taking your time and being diligent.